The next problem on the list, I'd like to look at number 46. Here, it's not as simple as that was a special case, the first problem, because you are on the axis. But here, if I look at this, well, I could try and mimic what I did up there, but then I'll notice that, you know what? 300 degrees is right there. So I know the point is in this quadrant somewhere. Right? Which indicates to me that, you know what? I know, oh, look, I'll tell you what. Here we go. This is 300 degrees, and this is 5. Well, I know it's in quadrant 4. So I know x is negative and y is negative, but I can't figure out what that is by guess. So what I'd do instead, I would say, well, let me use the formula. X equal r times the cosine of theta. R times the cosine of 300 degrees. And since we know what this is from chapter 1, cosine of 300 degrees is what? 1/2. And this quadrant, oh, I said positive. In quadrant 4, x is positive and y is negative. So x would be 5/2, and y would be r times the sine of theta, and y would be 5 times negative radical 3 over 2, and y would be negative 5 radical 3 over 2. So this point is the equivalent of moving 5/2 to the right, negative 5 radical 3 over 2 to the right. Oh, done. So, one set of problems, you rotate and you move in that direction. Another set of problems is move 4 units down, do not move on the x. And that's pretty much what we're doing. We're just really checking what do these mean in terms of one another. So if I take another problem, and I look at problem number, what's next? 48. Oh, 50. That's okay. 48. We'll do 50 afterwards. Hopefully it's not confusing you guys, out of sync. So again, this is a special case. I glance at that, I say, wait a minute, I know what this is. I really don't need to use those formulas. Well, I'm going to rotate to pi. I'm pointing in this direction, but since r is negative, I move in the opposite direction 1, 2, 3 units. I'm right there. So hey, guess what? In the rectangular coordinates, this is the point 3, 0. And you're right. Or you could not worry about this and say x equal r times the cosine of theta. The cosine of pi is negative 1, and that would be a 3. And y equal r times the sine of theta, and we know that the sine of pi is a 0, and y would be 0, and then you would say, well, hey, 3, 0 is that point. You want to use the formulas, strictly good for you. You want to look at the graph. I suggest you do both. Let's look at $50. Since you're not on the axis, the x or the y, I suggest you stick with the formulas. Again, plotting those is a good practice because you really need to get that before the next class lecture. So plotting those, you're really rotating to negative 3 pi over 4, and you're moving 3 units in the opposite direction. Okay, and if I look at, if I use the formula in this case, well, x equal r times the cosine of negative 3 pi over 4, and this is your chance to really start practicing some of the even odd identities. And let's see how this works. We know the value is radical 2 over 2, but where is 3 pi over 4? 3 pi over 4 is in the second quadrant, and this is negative, and negative times a negative would be a positive. And y would equal r times the sine of negative 3 pi over 4. Y would be negative 3 times the sine of 3 pi over 4, since sine is an odd function. That will be 3, and in the second quadrant, sine is positive, and that's radical 2 over 2, and that would be 3 radical 2 over 2. So here we have the point convert to in xy, that would become 3 radical 2 over 2 and negative 3 radical 2 over 2. So basically this is what we're doing to sum this up all in one simple problem. If you take the point x and y of 1, 1, you could reach that location by moving 1 to the right, 1 up. And here you are. If I convert, if I say, well, look, r squared is 1 squared plus 1 squared, which is 2, r equals radical 2, and tan of theta is y over x, which equal 1. That means theta must be pi over 4. So if I take r and theta and say, well, that point right there corresponds to radical 2 pi over 4. What that means, rotate to pi over 4 and move in that direction radical 2 units, and you are at the same location. And that's pretty much what it is. Just different ways of approaching the same value, because polar turns out to be much simpler to use with arcs than rectangular coordinates are. Now, if I want to go the other way around, that is, if I want to go from r and theta to x and y, or x and y to r and theta, on numbers 57 through 68, we have the rectangular coordinates of a point is given. We would like to convert to the polar form, and here we go. If I take problem number 58, so this is x and y. Alright, and we're looking at, this is a rectangular point, so this is x and y in this case. Adjusting the screen, here we go. So, the point 0, 2, again, they started with a special point. I really don't need any work. I could say, you know what? If I want to convert this to r and theta, rotate to pi over 2, and move 2 units, and there it is. Of course, there are an infinite amount of answers, but this is the simplest way. If I want to use, if I want to look at number 32, not as simple anymore. A key point in those 3 sections is for you to plot the point that is in section 4.1, 4.3, and 4.4. So if I move 1, 2, 3 back, 1, 1, 2, 3 up, here I am. I'd like to know, what is this angle and what is that radius? Well, let's see. R squared equals negative 3 squared plus 3 squared. R squared equals 9 plus 9, which is 18. R will equal the square root of 18, or 3 radical 2. You don't need to simplify. And tan of theta will equal, you would ignore the negative. And you would say the reference angle, the tan of which angle gives me 1, that's pi over 4. And then you would say in the second quadrant, what is pi over 4 in the second quadrant? That will be 3 pi over 4. So this point actually is the equivalent of r and theta. Rotate the 3 pi over 4 and move either radical 18 or 3 radical 2, and that would be the match. So one form of the section, you would go from r and theta to x and y. The other, you would go the other way around. And let's look at a couple more problems. Let's look at number 64. And on 64, if I plot this point again, this is my x and y, -2 and -2 radical 3. Let me put this up. So what I want to know, I'd like to know what is this r. Well, r squared equals a -2 squared plus a -2 radical 3 squared. R squared will be 4 plus 4 times 3. That's 16. R will be a 4. Keep in mind, I could have R to be plus or minus if I want. I'm not going to get into that. I suggest you stick with R being positive until you get the hang of this. And if I want to know what theta is, I'll say, well, tan of theta is y over the x. Remember, I'm going to ignore the plus or minus. And I would say I have a reference angle of pi over 3. And if I was to ask, regardless, what is pi over 3 in the third quadrant, that would be 4 pi over 3. So out of this, my r and theta are really 4 pi over 3. That would be the same location. And that's how we deal with points. The reason you want to find the reference angle on tangent, because if tangent is positive, you wouldn't know whether you're in quadrant 1 or 3. And if tangent is negative, you can't figure out just from the formula whether you are in quadrants 2 or 4. Now, the last portion of this, actually 2 more. Let me see. Maybe I'll include that in the next lecture.